Peanut butter as we know it today was invented in 1890 by an American doctor. He used it as a protein substitute for people whose teeth were so bad they couldn't chew meat. Nice. The best peanuts for making peanut butter are runner peanuts because they're uniform and roast more evenly than peanuts that vary in size. They arrive at the peanut butter factory already shelled. To make a 500-gram jar of peanut butter, it takes 565 grams. That's about 1,100 nuts. The nuts travel through a hot air roaster, heated to 204 degrees Celsius. The shaking motion moves them around so they roast evenly. More than 3,600 kilograms of peanuts go through this roaster every hour. When they come out, they've turned from white to light brown. Next, they're fast-cooled at room temperature, using suction fans that circulate air quickly. This rapid cooling process is critical. It halts the cooking and prevents the peanuts from losing too much oil. Next, the peanuts go through a machine called the blancher. It removes the outer skins by rubbing them between rubber belts. Then it splits the kernels and removes the heart of the peanut, which has a slightly bitter taste. But what's discarded doesn't go to waste. The skins go to farmers for pig feed, and the hearts go into bird feed. The peanuts land in a big stainless steel container. From there, they drop down into the grinder to be ground into a paste. At this point, the other ingredients go in: salt, sugar, and a small amount of hydrogenated vegetable oil, which acts as a stabilizer to keep the peanut oil from separating and floating to the top of the jar. Peanut butter contains no artificial colouring or artificial sweeteners. It has no preservatives either, yet doesn't need to be refrigerated. The peanut butter is finally ready. The mixing has heated the paste to 60 degrees Celsius, so goes through a cooling system to bring it down to 38 degrees. Now, it can go into jars. Peanut butter is a healthy, protein-rich food with plenty of vitamins, minerals, and fibre. It has no cholesterol, but it does contain fat. The good news is that more than 80% of that fat is unsaturated. In other words, good fat that may actually help lower certain cholesterol levels in the blood. The bad news is that the rest of the fat content is trans fat, or bad fat. It comes not from the peanuts themselves, but from the oil that's used as the stabilizer. If you want to avoid that, you can eat all natural peanut butter, which doesn't contain a stabilizer. You'll just have to stir the peanut oil that collects at the top of the jar. Once the jars are filled with peanut butter, they go through the capping machine. The caps have an aluminium seal inside. As the caps pass through a heat machine, the seal drops down and adheres to the top of the jar, creating an airtight seal. A machine prints the production date and expiration date. Those unopened jars of peanut butter will stay fresh for 1 whole year. Though with kids around, it usually lasts for just a week. A high-intensity industrial light bulb uses not only a filament, but also coils, electrodes, and mercury vapor. It's more durable, but needs a cool-down period before relighting. In 1809, a British chemist invented electric light. Over the next few decades, other inventors produced electric lamps and bulbs with varying success. The big breakthrough came in 1879, when Thomas Edison invented a carbon filament that burned for 40 hours. Then just a year later, he produced a bulb that burned for more than 1,200 hours. That finally made electric lighting feasible. The process starts by making the coil support, through which they'll later thread the filament. A glass rod 11 millimeters long is heated so that a pin just 28/100ths of a millimeter thick can be inserted. The pin is made of tungsten, a hard metal that won't melt under high heat. The rod and pin go into a machine that heats the glass and presses it into a mushroom shape. Then, tungsten wires are inserted. Then the wires are cut to the required. The coil support is now finished. Next, they build the mount onto which several other parts will be assembled. A quartz tube containing a coil, electrodes, gas and mercury is welded. Next, the bimetal switch, which cuts the current to the coil in the arc tube, is welded into place. Then the coil support prepared earlier is welded on. The coil support is bent down to receive the filament, which is made of tungsten. Next, they weld one end of the filament to the mount and feed the other end through the little circles of the coil support. Then weld it to the other side of the mount. The mount is now fully assembled. Next, a specific amount of pressure is applied to the bimetal switch to calibrate it. Then the finished mount is submerged in alcohol to remove any dust or other contaminants. It's dried for 10 minutes before having a liquid called zirconium getter applied. This draws moisture away from the filament. It's finally time to put the mount in the glass bulb. The sealing machine cuts off excess glass from the bottom, then melts what's left until it attaches to the mount. But how will this light bulb work? Well, the electric current travels through the filament to the coil inside the arc tube. The coil warms the gases, which then vaporize the small amount of mercury. The mercury vapor then conducts the current from one electrode to the other, creating light. A machine blows air in the hot glass while a mold creates the form. A special flame lets the glass cool slowly so it won't become brittle from the stress. The wattage and voltage is printed onto the bulbs. They're then run through an oven at 500 degrees Celsius to draw out any humidity or impurities that may be caught inside. The bulbs then go through what's called the tipping torch. This seals in nitrogen gas, which prevents the filament from overheating. Now the bulb is ready for its first test. A 10-minute burn to make sure it operates properly and there's no air inside. Finally, it's time to attach the socket. A cement is applied to the base and the bulb is hooked up. The bulb passes through a flame that cures the cement. The The last machine cleans the socket with acid, so it can be soldered at 2 points. The finished bulbs are put aside for 48 hours, then retested, before being shipped off and switched on.